Hello guys, this lesson is about polynomial division using the process of long division. And as the word says, a long division is usually a long process. Of course, it depends on the polynomial expressions you are dividing, but this suggests that there are other methods to divide polynomial expressions. In fact, once I show you how the long division works, I'm going to show you also the process of synthetic division, which is a much shorter process, but it has the disadvantage that many times is not going to work, while long division is a process that we always work, and that's the reason why we're going to start with the long division. Now, first of all, I want to show you how to divide the polynomial expression when the numerator is a polynomial which is made up by more than one term in general, and then the denominator is a monomial, so it's practically a polynomial with a single term. So let me show you some examples, and as always I suggest that you try to work these examples on your own first and then you check with me. Okay, so here is an example. Let's assume we want to divide these two polynomial expressions. So the numerator is a trinomial made up by three terms, and the denominator is going to be a monomial, so made up by a single term. So we have 4x to the power of 8 plus 8, x to the power of 4 minus 6x squared, and we want to divide this by 2x squared. Well, in order to understand what to do, well, let's recall what we do when we have something like 8 plus 6 divided by 2. Now, we all know that this is the same of 14 divided by 2, which is equal to 7. But you can actually rewrite this so instead of add up the numerator and divide by the denominator, you can actually divide 8 by 2 first, and then you add this result to 6 over 2. And then we know that 8 divided by 2 is the same of 4, and we know that 6 divided by 2 is the same of 3, and then 4 plus 3 is equal to 7. Of course, when we talk about numbers, we can combine whatever we have at the numerator, right? We can combine, in this case, 8 with 6. But if you look at the polynomial expression, we cannot combine the terms at the numerator because they are not like terms. They don't have the same exponents, right? So we have an x to the power of 8, we have an x to the power of 4, and an x squared, so we cannot combine those. Instead, what we can do is break down this division into three fractions, and then from there we are going to try to simplify. In fact, what we can do is we can rewrite this as 4x to the power of 8 and divide this by 2x squared, and then we have a plus 8x to the power of 4 divided by 2x squared, and then minus, because there is a negative 6x squared, 6x squared divided by 2x to the power of 2. So at this point we can simplify this. So we have 4 divided by 2, so let's look at the numbers first. 4 divided by 2 is equal to 2. And then x to the power of 8 divided by x squared is going to be x to the power of 6, because when we divide expressions, we need to subtract the exponents, so this becomes an x to the power of 6 plus, and then 8 divided by 2 is 4, and x to the power of 4 divided by x squared is x to the power of 2, because 4 minus 2 is equal to 2, and then the last expression becomes minus 3, x to the power of 2 divided by x to the power of 2, which is 1, and therefore we have an x to the power of 0, which is 1, right? And 1 times 3 is equal to 3. So we are dividing a polynomial expression of degree 8 with one of degree 2 to obtain a polynomial expression of degree 6 with a leading coefficient which is equal to 2. So this last one represented a simplified polynomial expression, so once the two polynomial expressions have been divided. Now, this process makes sense as long as the denominator is different than 0. So to be a little bit more precise with this type of problem, we should actually say that x must be different than 0. Because if x is equal to 0, then when x is equal to 0, this polynomial, we are dividing something from by 0, and therefore it's not reasonable anymore, right? So we will have an undefined result. Okay. Alright, so let's look at another example. Alright, so now try to do this by yourself. We have a 9x to the power of 10 minus 3x to the power of 15, and then plus x to the power of 20, and we want to divide this by x to the power of 5. So you should stop the video, try to do this by yourself, and then check with me. Alright, so at this point, I assume that you try to work this problem by yourself. So if we proceed at the same way we did earlier, we have a negative 9 divided by, so let's break this down into 3 fractions, negative 9x to the power of 10 divided by x to the power of 5 minus, I forgot to put an x here. So we have 3x to the power of 15 divided by x to the power of 5, and then plus x to the power of 20 divided by x to the power of 5. So here we have negative 9 divided by 1. It's like we have a hidden 1 here in front of x to the power of 5. So it becomes negative 9. We subtract the exponents, and we end up with x to the power of 5. And then here we have a negative 3 divided by 1, which is negative 3. Again, we subtract the exponents, x to the power of 10, and then plus x to the power of 20 divided by x to the power of 5, which is x to the power of 15, because 20 minus 5 is 15. So be careful, you don't divide the exponent, you subtract the exponents when you divide polynomial expression. So let me write this down, because it's important. So do not divide the exponents, okay? So you subtract them. And again, this is sense as long as x is different than 0, because we don't want to divide by 0. Okay. Alright, so now as exercise, try to do this by yourself. X to the power of 7 plus 3 x to the power of 4 minus x, and divide this by negative x, and then x to the power of 16 minus x to the power of 4 divided by negative x to the power of 4. So try this by yourself, and then you can check with me. Okay. I'm going to work at the first one on the left, x to the power of 7. We're going to divide this by negative x plus 3x to the power of 4 divided by negative x. And then we can put plus negative x divided by negative x, or you could put a minus. So this you could even write as negative x divided by negative x, is the same thing, okay? And what we get from here is x to the power of 7 divided by x is x to the power of 6. And since we have a negative, we divide positive by negative, we get a negative. And then here again we divide positive by negative, so we get a negative 3 times x to the power of 3, because x to the power of 4 divided by x is x to the third power. And notice how these terms are the same, negative x over negative x, which is positive 1, because negative over negative is positive. And therefore we get a plus 1. And then for this problem instead, we have x to the power of 16 divided by negative x to the power of 4, and then minus x to the power of 4 divided by negative x to the power of 4, or we could write as earlier plus negative x to the power of 4 divided by negative x to the power of 4. So this is equal to x to the power of 12, negative x to the power of 12, because positive or negative is negative. And then here we have 2 negatives, so this becomes positive. And since we are dividing the same term, so the one term by itself, we get plus 1. Okay, so I hope this process is clear. So what we did so far is divide the polynomial expression by a monomial, which is a polynomial with a single term. I should be a little bit more precise in these last 2 problems, and again saying that x is different than 0, because that's the only way this division makes sense. Okay, so now we're gonna go to divide the polynomial expressions using the process of long division. In this case, we are dividing by a polynomial expression which is made up by more than one term, so we have more than one monomial. Okay, we have a binomial, trinomial, and so on. Okay, so in order to understand how polynomial division works, let's think that we divide numbers, because the process of long division is actually equivalent of the process of dividing two regular numbers. Let's assume you want to divide 2274 by 5. Well, what we do, we ask ourselves, um, well, we cannot divide 5 by 2, so we go to 22, right? So we pick up 22, and I know that 5, 5 times 4 is going to give me 20 with a remainder of 2, right? So I'm going to write the 4 here at the top, and then I multiply 4 by 5, and this is going to give me 20. Now what we do with these two numbers, 22 and 20? Well, I'm sure you recall that you need to subtract these two numbers. So what we can do is put a negative sign here in front of 20. So we combine 22 with negative 20, and we end up with a remainder of 2. Next step is to bring down the 7, and then we try to divide 27 by 5, and 5 times 5 is 25, so again we have a remainder of 2. And in theory we should, even though we do this many times mentally, what we do is we should rewrite 25, put a negative in front so we can subtract these two quantities, and then we end up with 2. And then we bring down the 4, and we keep repeating the same process. So again we're going to have 4 times 5 is 20, we write this number here, we put a negative, we subtract the 4, and we get 4, which is our remainder. Now we could continue dividing this by using decimal points, but the point is we can also write this answer as so what we did is we divided 2274 by 5, and what we got is this number, which is the result, right, the quotient, so 454, and then we got a remainder of 4, which means we can write this plus 4 over 5. Now this number 2274, which is the numerator of this fraction, is I remind you, is called dividend. The 5 is called instead divisor, and the 454, which is our result with no remainder, is called quotient, and this 4 is called remainder. Okay, so in general, when you have a dividend and you divide this by something that is called divisor, you get a quotient, and you may end up with a remainder, and you're going to write your final expression as a remainder over divisor. That's what we did, right? So that's the dividend, this is the divisor, this is the quotient, and then remainder divided by divisor. So the same process will apply with polynomial expressions. So let's take a look at some examples. Okay, so let's assume I want to divide x squared plus 5x plus 6, and I want to divide this by x plus 3. Now this is the dividend, this is the divisor. Anytime you write the dividend or divisor, make sure that if there is any missing terms, for example the 5x was missing, you put a 0x here, and I'm going to show you some example of these. Or if you had I don't know, x squared plus 3 and the x is missing here on the left side, you write x squared plus 0x plus 3. But I'll get to those examples so you will better understand how this works when something is missing. Missing means that when we go from the largest degree to the lowest, one of the whole numbers in the sequence is missing. Okay, so how are we going to divide this by x plus 3? Well, what we do is we are going to compare this x squared. Okay, so we pick up the highest degree term for the dividend, we compare with the highest degree term of the divisor, okay? So I should ask myself, well, what do we do with numbers? We try to divide this, right? We divide the number here under this bar with the number here on the left side. So we can do the same thing. What's x squared divided by x? Or in other words, x times what is going to give me x squared? Well, the answer should be x. So what we do is we write down this x here at the top, okay? Now, at this point, what do we used to do with numbers? We used to multiply by the divisor. So we're going to do the same thing in this case. So we're going to multiply this x with x. So x times x is going to give me x squared. And then this x multiplied now by 3 is going to give me 3x. So I'm going to write this here. Do you remember when we wrote the numbers in the previous example? What do we used to do next? We used to subtract these two quantities. So here is my suggestion. Sometimes you may be a little bit confused to subtract a polynomial expression. It's not so simple as numbers, okay? But what we can do, something we can always do is instead of subtracting, we can once we write this expression, we can always change the sign of this expression. So practically we're going to change this positive sign here in front of x squared with a negative, and we change this positive with a negative. And now what we do is just add up like terms. So we're going to combine the terms. We're going to combine x squared with a negative x squared, which is 0. They simplify, right? And then 5x plus negative 3x becomes 2x. Okay, so instead of subtract, it's easier to combine the terms. Okay, if this is still confusing, please hang in there and you'll see that it becomes more simple. So we end up with 2x. What we do next, we bring down the 6. And now we're going to repeat the process. I'm going to compare these 2x with this x, and the 2x divided by x is equal to, or x times what is going to give me 2x? It's going to give me 2. And now I multiply this 2 by x, which is going to give me 2x, and I'm going to multiply this 2 by 3, which is going to give me 6. So again, I'm going to change the sign. So this becomes a negative, and this becomes a negative, right? And therefore, when we add them up, so everything cancels out in this case. So we end up with 0, which is our remainder. So how are we going to write the answer? So what we did is divide x squared plus 5x plus 6 divided by x plus 3, and we end up with x plus 2. Now, for all of you that actually notice that this term, this numerator, can be a factor in x plus 3 and x plus 2, you will immediately notice that what we got actually make lots of sense, because if you try to factor x squared plus 5x plus 6 with the strategy we learned in class, we need to find two numbers whose product is 6 and whose sum is equal to 5. So this is going to give me x plus 3 and x plus 2. And clearly, if I divide this expression by x plus 3, and I divide this by x plus 3, notice how x plus 3 simplify, and that's the reason why you get x plus 2. So you could ever work with this problem also by factoring and get the same answer. Okay? Okay, so I understand this may still look confused to you, and it requires some practice. So we're going to practice a little bit more, and then in the next lesson I'm going to show you some more additional example, even a little bit more complicated. Okay, so here is another example we can work on. So try this by yourself now, based on what you learned, which is x cubed plus 5x squared minus 7x plus 2. And you want to divide this by x minus 2. So you should stop the video, try to do this by yourself. Okay, so try to do this by yourself, and then check your understanding with me. Okay? Alright, so at this point, I hope that you already worked this problem. We're going to do this together step by step. So my dividend is x cubed plus 5x squared minus 7x plus 2, and we want to divide this by x minus 2. So what we do? We compare this x term with x cubed divided by x is x squared. You could ask yourself also, x times what is going to give you x cubed? Is going to be x squared. Now we multiply x squared by x, and this is going to give me x cubed, and we multiply x squared by negative 2, and this is going to give me negative 2x squared. What should we do next? We should subtract from the, we should subtract the expression at the top with x cubed minus 2x squared, and I told you that instead of subtracting, it's actually convenient to change the sign. It usually becomes more simple for students based on what I've seen so far. So we have a negative here, and I'm going to change this to a positive, and now we are going to combine the terms. So we don't need to subtract, we can just add. So x cubed, negative x cubed will simplify, 5x squared plus 2x squared end up to be 7x squared. And then we bring down this negative 7x. And what we do next is, again, we repeat this process, 7x, so 7x squared divided by x is 7x, or x times 7x is 7x squared. So we are going to write down 7x, we multiply, 7x times x is 7x squared, 7x times negative 2 is negative 14x, and now we're going to change the sign. So this becomes negative, this becomes positive, we're going to adapt. Notice how the first term, it will always simplify. If it doesn't simplify, it means that we didn't divide this correctly, okay? So always make sure that this first term, we always simplify. Now we have a negative 7x plus 14x, which is positive 7x. So it's a positive 7x, and then we bring down the 2, and we can still divide, because I can divide 7x by x, which is 7. We multiply, so we end up with 7x, and 7 times 2 is a negative 14. Again, let's change the sign. So this is going to be negative, and this is going to be positive. And now we can add up these terms, and we're practically done, because this and this simplify, and 2 and 14 end up to be 16. Now what we obtain in this case is, so our answer, so what we did is x squared plus 7x plus 7, and divide by x minus 2. And what we obtain is, we divide, so the dividend is x cubed plus 5x squared minus 7x plus 2, and we divide this by x minus 2 to obtain x squared plus 7x plus 7, and we obtain a remainder of 16, so we have 16 divided by x minus 2. Okay, so this is our final answer. Okay, so quotient plus remainder divided by the divisor. How can we check that this is correct? Okay, so how can you check it by yourself? Imagine that you're nobody you can compare this with, and you want to check by yourself that you actually did this correct. Well, if I divide, for example, 5 divided by 2, right? I know that 5 divided by 2 can be written as 4 plus 1 divided by 2, right? Which is 4 divided by 2, which is 2, and then we have a remainder of 1, so we have 2 plus 1 half is the same thing, right? Of 5 over 2. So if I want to check that this is correct, then what I should do is I will multiply this quotient, which is 2, by the divisor by 2, and then I'll add the remainder, right? And I need to get the divisor, so we'll multiply 2 by 2 and then add 1. Okay, so to apply our check in this situation, so what we're going to do is we're going to multiply this by x minus 2. So you multiply these two terms. If the remainder was 0, okay, so to check you're going to multiply these two terms. If the remainder was 0, we will get exactly x cubed plus 5x squared minus 7x plus 2. But since we have a remainder, we need to add this remainder. Okay? So let's see how this works. So we want to multiply, so we are checking this, right? So we're going to multiply x squared plus 7x plus 7, and we're going to multiply this by x minus 2, and then we're going to add the remainder. Okay, so if we do that, I use distributive property, but you can use the box method. So we get x cubed plus 7x squared plus 7x, and then if I multiply by negative 2, we get negative 2x squared, negative 14x, and negative 14. Let's combine the terms. X cubed is going to stay. 7x squared minus 2x squared is 5x squared. 7x minus 14x is negative 7x. Okay, and then notice that we have a negative 14, but this is what we should get, right? So in fact there is something missing here, which is the remainder. We have a remainder of 16. So once you multiply the divisor by the quotient, make sure that you add the remainder. We have a remainder of 16. And therefore, this becomes x cubed plus 5x squared minus 7x, and then negative 14 plus 16, which is plus 2.